Hello and welcome to the first part of my tutorial series about the very basics of Python. And yeah, I already made a Python tutorial which was a little bit more advanced, and it had a kinda higher difficulty level. And this is about the very basics, so if you're new to programming, new to coding, you are very welcome. Don't be confused about some of the phrases I use. Some stuff I'm telling, yeah, you will get it maybe later, maybe now, and just follow the steps and you will get used to a lot of things from time to time. Python is a wonderful language, and yes, let's start. In this part we are just installing Python, testing the shell, and we are downloading and installing an IDE, which is an environment for coding, which makes coding a little bit easier, or not only a little bit more easier, because every mistake, every miscoding, it is marked as a mistake or marked as an issue. So I guess you will need an IDE for the start. So there are many good tutorials about the Python basics. I just wanted to set up my own tutorial series where I can refer to the videos later on. Okay, now let's get started finally. So first of all, we are going to the web page of Python, which is python.org. We don't want to use a web store. We want to install it with, for example, Apple Store or the Windows Store. I don't know what is the name. Oh, here I can see it, Microsoft Store. No, we don't want to use it. We want to download and install it from the web page. So we are clicking on downloads, and now we are using or we have to choose which version we want to choose. I prefer a little bit older version. It is 3.10.11. You can download one of the newer versions. I don't recommend to download the latest version. You can get a little bit lower, for example 3.10 or 3.11, but for learning the basics it doesn't really matter which version you're using. So now we have to choose the right version. We have to scroll down. I scroll down obviously. And yes, I'm downloading the Windows installer 64-bit. Click on the download. I will add a python.x path. Install now. I will just use the default options, no advanced options. Now he's installing. And we should finish in a few seconds. So setup was successful. We can close it, and now we can enter the shell for the very first time. Here we have the shell, and yes, to open the Python shell we can just type py. To exit the shell we can type exit. We can type Python to enter the shell. We can type, maybe Python 3 should work. No, it doesn't. Now he is opening the web store, but we don't want it. Okay, if I type in Python 3.11, will this work? No. Okay, Python or Py will work. So we don't wanna use the shell that many often. In the shell we can, for example, test stuff and functions. But yeah, that's all about the shell in this part, because yeah, the basics are much easier to learn if you use an IDE, and that's what we wanna download now. So now we just googled PyCharm, and yes, I, for example, googled PyCharm download community edition, and what we're gonna head to is the other versions of Python, because we want to choose the community edition. The professional edition is perfect, but it is not for free. So to have a free IDE, we use the community edition. There are also wonderful IDEs which are not PyCharm, but for this tutorial we are just using PyCharm. So we wanna download it for Windows. It's downloading. Download is complete. Yes, now we are setting it up. I can use the yes, we want to update the path, and yes, PyCharm Community Edition. We want to create a desktop because that doesn't really matter. We can just use default options. An open folder as a project is always nice, so we don't have to create a new project. Yeah, and we want to update the path variable. Installing it, this will take some time. So now the setup is finished. I want to manually reboot later. Okay, now we can start PyCharm. Yes, I agree everything. I confirm. And now we can create a new project. We can just use the default variables. He already realized that our interpreter is Python 10. Perfect. And yes, here is our first project. So now we can write our first program. And this is called, yes, Hello World. So what we're gonna do, we just want to simply write a program which gives us back Hello World. So what we're gonna need is need is the print function. And in PyCharm, if we wanna type in something, the program is already guessing which you wanna or what code you wanna write. So when I type PR, he already guessed I want to print something or use the print function. And what we're gonna print is Hi World. So to run a program, we have to click on Run Main. We can also use Shift and F10. And now we have this little console, which you can clearly see Hi World, which is what we wanted to print. We wanted to print Hi World on the console. And yeah, we succeeded. That's all for this part. On the next part, we are doing much more interesting stuff than that. This was just setting everything up and writing Hello World. I hope this wasn't too confusing. Hello and welcome to the second part of my tutorial series about the Python basics. And yes, for this part I just prepared a little presentation for you. This will be a really short video where I just present the most common built-in data types, which are for data types you maybe even know if you have learned some languages before. This should only be a little overview. We'll have a separate video for any data type. I will make one video for integers and floats because they have some operations which work together and some functions which works hand to hand. So you can easily make a float out of an integer. But because before you get confused, let's start with the first important things about the built-in data types. So there are 4 built-in data types. What are data types? Data types are comparable to variables you learned at school, like a equals 4, b equals 2 plus a, and yes, c equals a plus b plus 500. Best comparable to integers and floats, which represent numbers. And strings are like, yes, text, or representing text or a list of characters or an array of characters. And Boolean are like sentences which can be true or false, like it is raining today is true, or it can be false, and you can combine 2 sentences with operations like and or. But before I'm explaining too much, let's start with the integer. Here are some facts about integers. Integers are numbers, whole numbers, like -7, 4, 500 or 70. A little bit unique to Python is that they have no limit and can be increased or decreased by arithmetic operations like addition, multiplying, or dividing. The floats are kind of comparable because they are just floating point numbers like 2.3, which in this case have a max limit, which is really high because a floating number uses 64 bits. For example, most integers, I guess, I'm not really sure, but I mean to remember integers use 32 bits. I'm pretty sure in languages like C or Java, your integers have a size of 32 bits. I don't know if this also goes for Python, but floats are 64 bits in Python, or use 64 bits in Python. Yeah, and they can represent any rational number, of course, only any rational number which is in the limit I mentioned above. So as already mentioned, string is representing a text and is surrounded, and that's important, by quotation marks, like a single or a double quotation mark. Text or text, yeah, I missed the ending quotation mark because there's always a quotation marks at the beginning of a string and quotation marks at the end of the string, but you only can combine similar quotation mark numbers. So a string can begin with 2 quotation marks and end with 2 quotation marks, or a text can begin with 1 quotation mark and end with 1 quotation mark, but a text cannot start with 1 quotation mark and end with 2 quotation marks. They are, as already said, representing a text, and they are a number of different characters, including digits. Yeah, also unique in Python. I don't know any other language which no characters as a single or unique data type. There's only a string, and characters are usually in other languages just a single letter or a single digit or a single space. And in Python they are just strings existing out of only 1 character. Yes. So now let's see how this looks in practice. So here we are again in PyCharm. I already wrote 3 other print functions like print2, print 2.5, or print2 is less than 3. Let's see what it is printing. I already ran the program, so you can see if you wanna spoil. Yes, after printing hi world, which is also a string, hi world is a string, there are the starting quotation marks and the ending quotation marks. The program is giving us a 2 and a 2.5 and a true, because obviously 2 is a smaller number than 3. If we type n minus 3, it should give us a false, and yes, perfect, it gives us a false. So we can also, like you learned it at school, you can also declare variables. You can name them a and can give them the value like 4 plus 6. And if we print a, we will see we will get a 10, because 4 plus 6 is a 10. And we can also ask the type of a variable, like type of a. And now we are gonna see class integer, because we learn later integers are also classes. What classes are, we learn later. And yes, what we wanna know in this video is just that a is an integer, and if we print type of 2 is greater than 1, we will get class type boolean, or in short, bool. The same goes for a string and, yes, of course, a float. I think it's unnecessary to show this. I would say we see you in the next video, and in the next video I also have some little tasks for practice. This stuff was a little bit too simple to imagine any tasks, but yes, in the next video I will show some tasks. You can type your solution in the comments. There will be an easy task, a more difficult task, and a harder task. The next video will be just about integers, but it will get a little bit more into it, so it won't be that sketchy as we handled everything in this video. So see you hopefully in the next video. I hope it was kind of understandable what I was saying. Yes, I wish you a wonderful evening, a wonderful morning, whatever time it is while you're watching this video, and yes, see you soon. Hello, and welcome to the third part of the tutorial series about the Python basics. After we had a quick look about every data type, now it's time to get a little bit deeper in the first data type, or not the first, but the first two data types, and these are integers and floats. I just want to show in practice what you can do with integers, the basic functions, and of course the arithmetic operations. Yes, you can obviously hear I have to make some effort to pronounce this, but I'm not used to say arithmetic operations. In German it is just arithmetische Operationen, and yes, that's why. But let's head back to the topic. So what integers are and how you declare them I showed in the last videos. As a quick reminder, it works like this. So we first have the name of the variable, and then we say equals to, and we have the name of the variable equals 33, for example. And I didn't mention it in my last video. The program usually starts with the first line and goes down forward, except there's a line which says you have to repeat this code, or which defines a function, but we will head to this later. So for now we just have to know that the program starts at the top and goes down line for line until it until it reaches the bottom. So although we have declared a variable, we can still still give a new value to the same variable. For example, we have my integer is 2 and here it is 33, and when we print our my int, we will get, of course, 33 because we said it is 33. And if we go one step earlier, he will print 2. As you see, he prints 2 because, yes, at this point we haven't told the program that the value of my integer is 33, so at this time it's just 2. Okay, it would be a little boring if we just can declare variables. We also can make arithmetic operations like addition, which is just adding another value to the integer. When we print my int now, it should be obviously 5. Same goes for subtraction. If we add a negative number or subtract, we will get -1. We can multiply, which is 6. And we can divide. And now we come to floats, because integers are only whole numbers. If we want to declare a float, we can do it like this. Now we declared a float. And now we printed not only one, but 2 floats, because my integer isn't a float anymore. It is, I'm sorry, I mean, my integer is not an integer anymore, it's a float, because, caused by the division, you don't have a whole number. 2 divided with 3 is not a whole number anymore, so we need a float for this, and in Python floats are automatically generated if you divide something which is not a whole number. If we have 6, it is also a float, but yes, we can of course make an integer out of 6 divided to 3, and now it is a 2. So if you write integer of and the number or the data type you want to make an integer of in the braces, you get an integer out of it. If we make an integer out of a float, I guess he will just, the value is rounded down. So even if we move 2.9 into an integer, it will still say 2, because although 2.9 is closer to 3, it always rounds down. What we can do the same for float, so we can say my float is the float out of 2, but it should be obvious, then it is 2.0 again. Yes. So now we had the most common operators. There are 2 more I want to show. I'm sorry, of course, I mean there are 3 more operations I want to show. So first we start with the exponentation. Exponentation, you know probably from school, is when you have, for example, you wanna multiply 2 with itself, but 4 times. This is exponentation. You, as I said, you know it from school maybe. And the same goes if you have two multiply symbols in a row, and then you will have the same function, and yeah, that's it. So if we print our exponent, myexp, we have 16. So we got 16, of course, because yeah, that's the value. So next is floor division. So if we still want to keep our integer through division, and we divide something where a rest should be. For example, if we divide 7 by 3, of course we can't, if we want to declare a variable, we aren't allowed to use white space. So if we divide 7 by 3, we get a float. Okay, of course I have to print my new variable. And yes, when we do the floor division, we will get 2 because, yes, in first or yeah, maybe second grade in elementary school you learned 7 divided by 3 is 2 rest 1. I learned that in school in second grade. And yeah, so the floor division gives us the 2. And now if we want to know what is the rest of a division which is left over, we have, I call it my modulo, because we have the modulo operator. So the modulo operator gives us the remainder of a division. And if we now divide, if we use the modulo operator, which is the percentage sign, we should get nothing because we again forget to print it. So if we print it, it should give us 1 because the remainder of the division is 1. If we divide it by, yes, 200, 7 isn't divisible by 200, or it is divisible, but it will give a float which is smaller than 1. So the remainder is still 7, which goes up until we reached 700. So 199 is the largest value where we have yeah, a valuable less than 1. So we have 199 as the highest possible value. So here you have a last overview about every every operation, arithmetic operation, which you can do in Python with our integers. If we run the program, of course, 2 plus 3 makes a 5, 2 minus 3 makes -1, 2 multiplied with 3 makes 6, and so on. The rest should be obvious. So last but not least, we are already finished, but I would like to show you some tasks you can do for practice. So here we are. These are the tasks I thought of. And yeah, let's solve the first task together so that you know how the solution was meant, or yeah, how the tasks were meant to be solved. So we have at our first task try to print 28 by using the operators multiply, addition, and the number 13 once and 2 twice. This is really easy because we just have to use 13 once, 2 twice, because we first multiply 13 with 2 and then we add another 2 and we should get 28. Perfect. So for the next tasks, I will show you the solution in the next video. You have to reach 16. You can print the number 16 at the end, but you are only allowed to use the numbers 13 and 10 and the operators multiply, division, modulo, and the floor division as often as you want. For example, we can use 13 and can divide it with 10 and divide it with 10 and divide it with 13. But in the end we won't get 16 but 0.0.1, not 0.1 but 0.01. Yes, that's not the solution, but we want to reach the 16. So instead of 0.01 there should be, yes, 16. So if you have a solution you can post it in the comments, or yeah, you can just think for yourself, and in the next video I show you my solutions for these tasks. And yes, I wish you a wonderful evening. Here it is close to midnight, yes. But I wish you then a wonderful midnight. Have a nice day, have fun with programming, and see you in the next video where we are doing everything I know about strings. Hello and welcome to the fourth part of my tutorial series about the Python basics, and now we are heading to the topic strings. Before that I will just give you the solution for the tasks. And yeah, the tasks which I imagined in the last video, and I didn't imagine them correctly because the last task was unsolvable. Because if you got only 1345, you also need the operators multiply, and you also have to use the large number as often as you want. And if you have that, you can have our large number divided with 10 so that we get 13. And yes, that number we want to multiply with so now we got 65. I'm really sorry, but at the moment this are my first videos, not many people are watching them. I hope no one was confused by the task I gave. Yeah, next time I will think a little more before I imagine some tasks. Yes. So, but now let's head to our next topic, the strings. What is a strings? A string is a list, or a collection of characters or signs or letters, like any other word, any text. For example, a string is hello world. If we have our print function, it accepts a string and we can here type anything, and anything is in that case a string. And yeah, we get a string. The string is printed, and yeah, we get our string, which is in that case ASDFKJASFD, our white space, and then the other signs. So a string can also be digits, but these digits are not meant to be calculated with. They are part of the text in that case, and yeah, as long as you have the quotation marks, the collection of our digits is not a number but a string. So yeah, how do you define or how do you declare a string? As already mentioned, strings are marked with quotation marks at the beginning and at the end of the string. There can be an empty string like this one, which begins and ends with quotation marks. You can decide for yourself if you want to use 1 or 2 quotation marks. And you can also use quotation marks in the string. For example, if you want to write I love my husband, which is named Martin, we will get a mistake. Why we will get a mistake? Because we tell the program the string ends here and a new string starts here. But the string doesn't know that Martin and our quotation marks also are part of the string. So what we're gonna do, we can use a backslash. If we put a backslash before our quotation marks, we mark them as part of the string. But we can also just use the one quotation marks, because if we use one quotation mark, the program is waiting and looking for another single quotation mark and not the double one. So what you can do with strings is a lot. Later you will know how useful they are and yeah, how important they are for programming. Now you're thinking maybe, why do I need them? But in our next topic we get a little bit closer to things where our variables will get more hand in hand. For now I just want to show you some functions you can do with our strings. One important function is the length function. So what is length? Length gives us obviously the length of our string. And with that I mean 41, which is the number of signs the string contains, including the white space. We can also count a substring in a string. What is a substring? You for example, in this string A, there is the word love. And we can show us how often the word love is contained in the string. For that, we type our variable we named A. And yeah, with the function count, he already mentioned some functions which we can use with strings. If we type a.count, and that in our braces we type in our substring, love in that case, he will count how many instances of love are in the string, in that case 1. Or we can even have one single character like I, and now we get the value 4 because there's an I, there's an I, there's an I, and yeah, there. So 4 I's. And of course, if we have the uppercase I, we get 0 because there's no uppercase I. So in a string, it's important to make difference between an uppercase and a lowercase letter. So apart from that, there are special characters in a string. I already mentioned, if you type backslash and then a quotation mark, the quotation mark is printed. Oh, first of all, I should print the variable A. So now it is printed, and because of the backslash, the quotation mark is also printed. If we type an N instead of the quotation mark, you see he will begin a new sentence. And if we type a T, it is the T characterizes the tab. So yeah, it's like we are using the tab key at our keyboard while writing a text. And that's probably it. That are strings. So there are a lot of more functions you can do with strings, like getting an index, getting a substring, but we won't get to anything. We won't get any benefit if I show you 1000 functions. But as you can clearly see on this website, there are a lot of functions you can just do with a string. There are also packages you can import, like string, and then you get even more functions. So with that being said, I am finished, and I hope you kind of enjoyed the videos through my spelling mistakes and stuff like that. I hope I see you in the next video. Have a nice day, evening, and see you. Bye bye. Hello and welcome to the fifth part of the basic tutorials about Python. Now our next topic are the booleans, the last data types we had in the overview. And what booleans are, I already told. As a reminder, booleans can either be true or false. And to decide whether a boolean has a true or false value, we have our boolean operations. So how do we declare a boolean? You can declare a boolean by just typing my bool to declare a variable, and the boolean can either be true or false. So if we print the boolean, we should get true, and false if we get my boolean 2. So this is pretty simple, but booleans are really important for if conditions and any conditions. Booleans play a major role in programming. And what kind of boolean operations can we do? So the first and most important operation is the not operation. So my boolean is true, so it's obvious not my boolean should be false, and not my boolean 2 should be true. So this is just not. Let's comment it with not. So next we have the AND operator. So we have my boolean and my boolean 2. So of course the boolean 1 is true, the boolean 2 is false, so my boolean and my boolean 2 is also false. It's like if I'm saying it's raining outside and it's not raining outside. This can't be true because I say and not or. Or is the next operator. So while if we have the AND operator, one of the booleans has to be true. In the next one, in the OR operator, it's enough and it returns true if only one of the booleans is true. So we can even say or false, and it will also be true. So if we just print, to make it even more obvious, if we print true or false, and if we print true and false, it gives us true in the first case and false in the second case. Now that we don't lose the overview, I just uncomment or comment the last 3 entries, so they won't be shown on the console, and we have our 2 booleans we just printed, true or false and true and false. So obvious we can do that in braces and can also use the not operation. So it's also false because not true or false is false. So next to and or, we also have some other operator which I just call the head operator because sign looks like a head. This one. So this one will return true. Why will it return true? It is called, I know it as the XOR operator, exclusive OR, which means we have 2 booleans, one has to be true, one has to be false. Which is true in that case? If both are true, it should return false. If I don't forget the brace, now it returns false. And of course, if both booleans are false, also returns false. So the opposite of that is the XNOR operator, and yes, then in that case it's the entire opposite. Both boolean must be either true or false, and that's it. You have you can also declare a boolean by just having, you can declare booleans with comparison. Yes, now I have something on my tongue. You can declare booleans by a comparison operator. Man, this is hard to spell. Comparison operator. I got it. So my boolean, for example, can be 3 is less than 4, which is true, and my boolean can be 4 is more than 1. And now if we print my boolean and my boolean 2, we also get 2 true, because 3 is less than 4 and 4 is greater than 1. And in this case, if we say 3 is less than 2, we get false. So we can also say equals. It's really important that when we say 3 equals 2, which is obviously wrong, but if we wanna say 3 equals 2, we have to add a second equals, because 1 equals is if we wanna declare a variable, and 2 is for the comparison operator. So important, 2 equal signs. So of course this is wrong, but if we have a 3, it is true again. So we can also say 4 is greater equals 4. So this includes when the number y to it is smaller, or when it's the same number. So it will return true if it's a 4, also if it's a 3, but of course not if we type a 5, then it's false. So these are all the operations I have in mind at the moment. If there are even more, I will write it down in the comments. I will maybe mention them in the next video. But this should be all considering booleans. In the next video we are gonna focus on if conditions, and for an if conditions we need these booleans. So the if conditions are the perfect topic to handle in our next video. I hope you enjoyed this video as much as you could, and I wish you a great evening, a great day. See you next time, and bye bye. Hello, and welcome to the 7th part of my tutorial series about the Python basics. This one will be the shortest, I guess, because we are just talking about the input variable, not the input variable, the input function. And first of all, every program we wrote in the last 6 parts, we just were able to run, and then on the console it was shown what we wanted to be printed. Now we wanna ask for user input, and the program will, while running, the program will ask at some point what the user has to type in. It will ask for something, and depending on what the user types, the program will run different routes. So how does it look? We can declare a variable, which is in that case a, and use the function input, and in the braces we type a text. The text will be printed in the console, but it has to be interpreted as a question, or as the question for the value. What are you willing to offer us will be printed. If we run the program, we can type something, and yeah, after we typed a value, the rest of the program will be executed. The value we typed will be saved as an A, but as you can see, nothing happens with the program or with the value the user typed in. So what we're gonna do, we will use an if condition, and depending on the if condition, different things will be printed. For example, we type A equals 20. We can print that's what I wanted to hear, buddy, and else print no. So, as you can obviously see, there is one issue, and the issue is the input function asks for user input which will be saved as a string. If we will ask the type of A, it will be answer us as a string. So what we are gonna do is we ask for an integer, or no, we are using the integer function which will transform our string into an integer. So now we type in 20, and yeah, we get that's what I wanted to hear, buddy. We can run the program again and type 12, and we will get the long no. If we have a program which is that simple, we can just copy the code of the variable we are declaring, and instead of A, we can use the function in the if condition, and now the code should be executed the same way the code was executed before. We can also type \n, so we have a new line where we write our offer, and that's probably it. There's nothing else I wanted to show you, but I was thinking it is a little bit boring to continue our program or our tutorial series without having the opportunity to ask the user for any input. And yeah, in our next video we are handling loops, which will be much more complex, and the video will be much longer. Besides that, I wish you a wonderful evening, wonderful night, wonderful morning, wonderful dinner time, whatever time it is. Have a wonderful day. See you soon. Bye bye. Hello and welcome to the 6th part of my tutorial series about the Python basics, and I hope it is the 6th part because it's pretty late and it's debatable if I am able to count correctly, but maybe my mistakes will be even funnier this time. I am going to show you if conditions. So what are if conditions? So before, usually the compiler went to the first line, and the entire program from the first line to the last line was executed. But an if condition with the if keyword and a boolean afterwards has its own code, and dependable if the boolean after the keyword if is true or not, the code after the if condition will be executed or not. So how do we know if the code belongs to the if condition or not? Python is really special in that case because it uses indentation. So we add a level of indentation, and everything which is written in that indentation will only be executed if that if condition is true. Of course, 3 equals 3, so my boolean is true, and the print 1, 2, 3 is executed. So if we type not my boolean, it shouldn't be executed anymore, and it is not. He will of course print my boolean and my boolean 2, because these two variables, or the function print my boolean and print my boolean 2, is not part of the if condition, because there's no level of indentation. So to sum it up, we have the keyword, we have our boolean, and of course I forget to mention it, there has to be a colon after the boolean. Without the colon there will be a mistake, colon expected, so we add a colon. So if we can ask for an if condition in the code, we can also ask for an if condition inside an if condition. If true, and yeah, we have to add an additional level of indentation. We can write in that new condition, for example, hello my dearest friend, and because the boolean after the first if condition is false, the if condition here won't be executed, but now we have a boolean which is true, so the number is printed and the string in the second if condition is also printed. So there are two other keywords I want to show you. First one, elif. So if this condition is false, we can add an elif condition. And if the elif condition is true, the code which is below the elif condition will be executed. Of course, we also have to add the layers of indentation, but if we do that, the code will be executed, but only if the first condition is false and the next condition is true. If the first condition is true, the elif condition will be ignored. So apart from that, there's another keyword which is simply else, and this will be printed regarding of the conditions before. We can add as many elif conditions as we want. So the third elif condition will only be executed if the first condition is false and the second condition is false. And the else condition will only be printed if there's no true condition above. So else is equal to elif true. So as I mentioned before, we need a boolean, but we can also write, instead of the boolean, we can write a variable like to and now it won't get us an arrow, but it will try to interpret the integer as a boolean. So any value beside 0, no matter if it's a float or integer, will be interpreted as a true value. So 1.3 will be printed, except we type in 0. And yeah, even negative numbers are interpreted as true. We can also write a string, and yeah, anything beside an empty string is interpreted as a true boolean. So just an empty string is interpreted as false. So we are finished now. I don't have anything more to say about Yeah, if conditions. I hope you liked the video. It was understandable, and we see you in the next video, which will be really short. We are just talking about, yeah, user input. Besides that, I wish you a wonderful evening, wonderful night, wonderful dinner time, wonderful morning, whatever time it is. Have a wonderful time and see you. Bye bye. Hello, welcome to the 8th part of our tutorial series about the Python basics. Now heading to our next topic, the loops. So I may be asking, what are loops? In our last chapter, not our last chapter, our chapter before our last chapter, we discussed if conditions. So if conditions, they had the characteristic that you first have the keyword, which is if or else, then you have a colon, and after the colon you have a new line, and then add a level of indentation, and in that level of indentation you write lines of code, and these lines of code are only executed if the if condition is true. Now we don't have an if condition, but we also have a keyword, a colon, and in the next we have lines which have a level of indentation, but loops mean repeat something. So the code which is written in the indentations, or which have the level of indentations, will repeat it, and they will repeat it as often as you define in the loop. So we should start with a loop. The first loop I want to show is the while loop. So we type in the keyword, which is while. Now we type a condition, a variable. We can type true, then we can, which is a condition, and then the colon, then our next line with a level of indentation, and then we can write print 1, 2, 3. So before you skip this video, I'm asking you before executing the code, what do you think, how often will this line be executed? We can press play and see it will be executed endlessly. So I'm shutting down the program, and yeah, it's because while this condition is true, this code will be executed. If we also have another line which is in the same level of indentation, it will also be executed. So what we are gonna do, we first have to declare a variable, for example a. And now the simple way of writing it is, while a is greater or equal than 0, and now in the level of indentation, because this code will also repeat itself endlessly, so we also have to decrease our a by 1. And now you see the loop will execute the lines 3 times, I guess. No, I'm stupid. Of course it is 4 times, because when a is 0, it will also be executed. So it are 4 times when a is 0, 1, 2, and 3. So we can also print a. And now we see when a is 3, when a is 2, when a is 1, and when a is 0. So we can make it even simpler, because when we were discussing if conditions, I told you integer is always interpreted as true except it is 0, then it is interpreted as false. So the code also works if we just type in the variable, which in that case is a. Everything works fine as it should. So this is everything about the while loop. The next loop I want to discuss is the for loop. Yeah, I hit the wrong button on my keyboard. So the for loop is something like for I in range 3. So what happens now is pretty simple. We already defined a variable which is I, and if we now press print I, it will give us a 0, a 1 and a 2, because in range 3 means starting from 0, ending with 3, so it means I has always to be less than 3. And yeah, so I starts with 0, then 1, then 2. So if we can say it even more simple, we can just say if we want a loop which does its thing 3 times, we just type in for I in range 3 and it will be executed 3 times. We can also type in 1 and type in 4. Now the loop will start at 1 and end at 3 because less than 4. And we can even add one more integer, which is 2. So now it will only print a 1 and a 3 because the last integer defines the amount which is added to the 1 for each loop. Yeah, for each time the code is executed. Okay, next one is also a for loop, but now we want to define a string first. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, W. Yeah. Now we have the alphabet, and what we are gonna do is we want to loop through this alphabet. So the for loop for this is even simpler. For C, in A, colon, print, that was my mobile device, print C. Now if we execute this code, we see every letter which is printed. Every letter of the string will be printed. Why the letter is printed we will discuss in, the next video. Yeah, in the next one we are doing lists, or in the video after. But yeah, for the loops, this is everything you should know. So of course you can have a while loop. In the while loop we print A. Now we can also do the keyword in the while loop, which is a for loop. For double A in range 0, 1, 5, we print double A, and we can even have another loop in the loop which is in the loop, so loop in a loop in a loop. And this is for C in, now we can even type a string, and now we can print C. So you can guess that letters are printed really often when we execute this code. Yeah, because I forgot that I have to decrease the A. It will be looped endlessly. But now we see we have a lot of letters. That's why he firstly does this loop, then he goes into this loop, and then he goes into this loop, which has many instances because there are many letters in that string. And yeah, if he iterated through this loop once, he will go back. AA is then increased from 1 to 2 until this loop is done, and every instance he loops through this loop, he will also execute this loop. And yeah, when this loop is finished, it will start again because we also have this loop. So as you can see, as more loops you have, the longer the program needs to do its thing. Yeah, for this part it is everything I wanted to tell you about loops. But yeah, one thing I forgot. In loops you can also do an else. keyword, or you can add an else keyword, and by that the else will be executed simply after you finished the loop. So for example, in our for loop, after we type the keyword else, you can now print something, for example something, and now the last thing which is printed is of course something, because when everything is done, the last loop is a loop through the string, and when it is finished, it prints something. Of course, it prints something at every end of the loop, and the loop is executed much and many times. Okay, but now we are finished. I hope you could understand what I was telling, or what I was trying to tell. See you in the next video, and I hope you have fun at coding. Bye bye, see you. Hello, and welcome to the 10th part of our tutorial series about the Python basics. Now finally heading to lists. What are lists? Lists are a collection, kind of storage for multiple data types, multiple variables. It's hard to define it. It's maybe a little bit comparable to strings, because strings store a number of characters, like the word hello stores an H, two L's, one E and one O, and a list can store near everything. So before I talk too much and confuse everyone with my talking, I will just define a list to make it even more clear. We call our variable mylist, and variable mylist has a 1 and a 2 and a 3 and a 4. So now if we print mylist, we'll get in square brackets 1, 2, 3, 4. So this is the main characteristic of a list. It's always in square brackets. So we can also print individual elements of this list. For example, we can print mylist and the first element, which has the index 0. This is typical for programming, that the first element of a list, of an array in other programming languages, is always the number 0, not the number 1. After some time you will get used to it, so don't worry. So there are other options to print out the list. For example, we can print mylist 0 to 2. Now it will print or give us the first and the second element, because it will start at 2 and head until will stop before reaching the third element with the index 2. We can also print mylist -1, and now surprisingly it will give us the last element of the list. Each variable stored in a list is called an element. So the first, the second, the third and the fourth element of a list. Like a string, if we want to have or get the length of a list, we just type length of mylist, and now it will give us a 4, because the list has 4 elements. We can also add new elements to the list. First we have to type in the list. We want to append something, and then we type append, and then we can append the number 69. And when we print our list now, it will print 1, 2, 3, 4, 69. And here it will give us, of course, none, because the function append doesn't have any return value. It returns none, and none stands for nothing, or null. So if there are lists and lists are able to storage near to every data type, there must be lists in list. And yes, there are lists. So now we are using our loops. We are first losing for e in range 0, 10. Don't forget the colon. Now we type in for I in range 0, 5. And now we can add elements to the list. So before we do that, we first have to define an empty list. We call it new list. And in this part of the for loop, we are defining another list. We call it temp list. Now in this part of the function, we are appending to the list. We type in temp list.append, and because we are not that creative, we just append I. Of course, now we also have to append the temporary list to the new list. And if we now want to print the list, we just type print new list. And if we want to print only the lists which are stored in the new list, we can just type for list in new list, print list, and now every list should be printed. We can run the code, and I've made a mistake. List.append, of course we have to append our temp list, which I forgot to mention. So now, as told, we have a list containing lists which only contain the values 0, 1, 2, 3, 4 as an elements, and the elements of the big lists are the smaller lists. If we iterate through the list with the other for loop, we can print every list. And another way to get every element of a list or list is just the same way as we appended the elements to our list. We just type in list, new list. I'm sorry. We type just new list, I. And now every element is printed if we don't forget to write the print function because we are too sleepy. And now we get every element in the list of the list. So now I don't have any notes on my paper anymore, so I guess we are finished. Before finishing the video, I just want to show you a list of how many functions we can do with lists. I will here's another site. There are many functions with lists, so feel free to research. Now I am finished. Have a nice evening, night, morning, dinner time, whatever time it is. Have a nice day. See you hopefully on the next video. Goodbye, bye bye. See you. Hello and welcome to the 9th part of our tutorial series about the Python basics. This part is about functions. So what are functions? In our last videos we already used functions. We already used functions in the very first video, in the very first part of the tutorial, and functions are a block of code which defines something the program is later possible or able to do. So yeah, this definition is a little bit confusing. What does that mean? For example, print is a function. Print is something which is already defined, and yeah, what needs an argument and what returns doesn't return something, but which does something. So before I give any more confusing definitions, I will just write a function and explain everything while writing the function. So the keyword for a function is definition. And after that, like a variable, we have to name a function. Now we name our function do nothing, be lazy. And yeah, what arguments in the function are we learn later. Now we just have to know that there are braces after naming the functions, and then of course the colon like we had in a while loop, like here, or in a if condition in our previous videos. So after the while loop, it's Python, we have to add a level of indentation. And in that level of indentation we can write whatever we want, as at least it has to be code. But yeah, we can write print I am a lazy person, too lazy to do anything. And yeah, now we can call this function. So if we just press play, nothing will happen. There is no printing, nothing. But we can call the function like we can call the print function. We can call now our own function. And now it is printed, I am a lazy person, too lazy to do something. We can... No, that was something else. So there are not only functions which just do nothing. They are not only lazy functions. There are also functions who need arguments, and when we want to write a function which needs arguments, we just type some variables in the braces after the name of the function, for example a and b. And now we say, hi, I'm a lazy person, too lazy to do anything. Then we print a, then we print b, then we print a plus b. So what will happen now? It will give us a mistake because it is missing two required positional arguments, a and b. So back to our function we are calling, we need to type two arguments for a and b, which can be 2 and 4. And yeah, because I'm using an IDE, it already tells us which variable gets which value. So the a variable gets the value 2, the b variable gets the value 4. And now if we execute the program, it first prints 2, then 4, then 6, because that's how we defined it in our function. We can also add the variables to the string we are printing. And Python has a cool way to implement some values into a string. Before our quotation marks we type f, and then now we can add curly brackets in the string like this. And yes, if we are typing our integer value in the curly brackets, it will print the integer. So that was just for an example how you can implement values in a string. I didn't say that before, so I'm saying it now. So functions don't only print or do nothing, they can also return a value. For example, a function can multiply, can take two arguments and multiply them. We define a new function which is called do something. It needs two values, and it returns a plus b. So if we call our function do something 2 and 4, it will do nothing. If you don't believe me, I run the code. It does nothing, and it does nothing based on that we didn't print anything. So now we are printing our function, and it prints 6 because, yeah, this function is meant to calculate with our arguments and return another variable, which can be an integer. We can also return it as a string. So now 6 is now a string. We can do anything we want. But not only the functions we define, even some basic functions work in the same way. For example, if we have a string and we type in upper and wanna print it, it will give us the uppercase letters of A, S, D, L, F, because yeah, we had the function upper. Now this function is the function of an object, and what objects and classes are, we are gonna handle in yeah, I guess about not the next video, but the video after the next video. Last but not least, I want to explain what what default values are. For example, we can say x equals 2, b equals 2. Now we can print everything like before. 6 is now a string. We can also print do something without typing any arguments, and it will still give us 4 is now a string, because as a default value a is 2 and b is 2. So if there's no value which we mention in while calling the function, it will rely on the default values. So if we want to do some good conceptual code, we can also do stuff which is not really necessary, but yeah, helps others to yeah, understand the code better. First off, we can say a must be an integer if a is always meant to be an integer, and the code wouldn't work if a is, for example, a string. Now in that case, if we type in to do f something and instead of 2 we type fs, it should give us a warning, because it here you can read accepted type integer got string instead. So the last thing I wanna show is the purpose statement. So we can add three braces, or not braces, I mean three now it's got me. 3 quotation marks, and it can be 3 double or 3 single quotation marks, but 3 quotation marks, then we press enter, and then we are able to write a purpose statement. For example, yeah, does something, returns a plus b, a cool integer, the coolest integer. So why am I doing that? What does it do? If we lay our cursor above the function, we see what we just typed in. It's like the definition, the explanation of the function. It does something, returns a plus b, then params, a is a cool integer, b is a cooler integer, and returns the coolest integer. So it's another way of preparing the code to be able to be used for other creators, other people who will read the code. So you should always do purpose statements. It's some aesthetic. If you are really just doing the code for yourself or just trying something, you don't need a purpose statement. But if you want to write the code for others, if you're doing a project in a team, always write a purpose statement. Yeah. It is some aesthetical thing, like when you have larger code, you always should write global variables with uppercase, like a is 3 and not small a is 3. Yeah. So I hoped you could learn something from that video. I hope you're doing fine. Have a great evening, night, morning, whatever time it is. See you in the next video. Goodbye. Hello and welcome to the 11th part of my... Sorry, that was my girlfriend in the background, if you could maybe hear her. So in this part we are gonna do everything about classes, what classes are. With classes we are able to define our very own data type. We had strings, we had integers, which are primitive data types, and now we are heading to the complex data type. So like a variable, a function, a class begins with a keyword, in this case the keyword class. Now we have our the name of the class, which we are gonna call protein shake. Now the columns, and what we don't need are the brackets, but like a function we can add our purpose statement, which is tastes tasty. Because why not? If we press enter, there's nothing. So what is a class? A class, as already say, is a blueprint of a new, more complex data type like a protein shake. If we defined our very own protein shake, we can do instances of this protein shake. For example, we can create our very own protein shake, like fudge brownie equals protein shake. So important, when we define a new protein shake, we have to use the brackets, but not when we define the class itself. So the protein shake is like the class, the blueprint, and the fudge brownie is the individual protein shake. If we want to be more clear what I'm meaning, I will tell you the next part of the class, which can be the constructor. So in the class we can define our very own functions which all refer to our class or even our object. And the first definition is the constructor definition. And first we have the keyword def, and then we will use two underscores. Then we type init, and then again two underscores. So the compiler knows, oh, now there is a constructor. then important, we have to use brackets, and yeah, the first argument, which is always inside a constructor, is self. So it is referring to itself as an instance. Now we can add more variables, more arguments, like amount of protein, which is an integer, and flavor, which is a string. And yeah, inside the function we will type self punct. As you can clearly hear, there's something on the couch behind me. Okay, we have to type self punct amount of protein equals amount of protein, and in the next line we type a self point flavor equals flavor. So why is that important? Now if we type 1, it gives us obviously a mistake, a type error, the exception, because we didn't define our arguments. Like that one. Now we can define another protein shake, like strawberry cheesecake is a new protein shake which has 28 grams of protein, and yeah, the flavor shall be strawberry, but the cheese is missing. So now if we print protein shake, it will give us class main protein shake. So we can try to print fudge brownie, but we will just get that we have an instance of an object. But now if we print protein point flavor, we will get something smelly, because now we are referring to the individual string which has the instance fudge brownie. Same goes for the strawberry cheesecake. So if we print the flavor of the strawberry cheesecake, we will get a strawberry, but the cheese is missing. And this is because every variable is defined individually for the instance of the object. You call the instances of the class objects, and the class you call obviously class. Class is like the blueprint object is like the individual version of the class. Like human is a class, but you are more like, okay, that sounds wrong, but you are an object. The person which is maybe sitting behind you, watching you, is also an object. But the person or the dog itself, as a word, is a class. Your personal dog, which you named Bello, is an object. So next to the variables of the object, we can define class variables, like purpose. Purpose equals gaining muscles. So now we are printing fudge brownie point purpose and strawberry cheesecake point purpose, and it is the same. And now this is funny because if we change the fudge brownie purpose to getting diarrhea, oh, I hope I spelled it correctly. I obviously didn't, but you know what I mean. Then the purpose of the strawberry cheesecake is still gaining muscles, but yeah, the fudge brownie purpose is now getting diarrhea, but never override class variables, just rely on the object variables which are in the constructor. Now let us define another function, which is def, and yeah, the function we call print its values, which also has the self. And now what the function does, it simply prints the self amount of protein as a string. So we type f, the string, use the brackets, and yeah. Let me just finish, then I explain everything. So what I wrote is an individual function for every instance of the object, and now if we type fudge brownie prints its values and strawberry cheesecake print its value, we are getting 22 grams of protein and tastes like something smelly, and 28 grams of protein and tastes like strawberry, but the cheese is missing. Boah, that's hard to pronounce if you are a non-native speaker. We can also define function which alterates variables like def take the shake and let it stay outside for a few days. And this changes self.flavor to the worst nightmare you will encounter. You and your stomach will encounter. And now the strawberry cheesecake will stay a little bit outside. And after staying outside, it tastes like the worst nightmare you and your stomach will encounter. So maybe I have to mention you also can have other arguments. You can put the worst nightmare your stomach will encounter as a default variable, and yeah, self.flavor is a. So if you don't use an argument, it will just get the worst nightmare you and your stomach will encounter. Otherwise, it will get a flavor which you decide. So that's it for this video. In the next video, I will talk about maybe even we are heading to inheritance. Yeah, inheritance. But for now, this video is over. I hope you could enjoy the video. Have a nice day, evening, morning, whatever time it is, dinner time. See you in the next video. Bye bye. Hello, whoa, whoa, whoa. and welcome to the 12th part of our tutorial series about the Python basics. Now, in our last part we discussed about classes, which gave us the opportunity to create our very own data type. And as a quick reminder, I just simply will write a class in a few seconds. We have the class human with a constructor function, like this one. Self size equals size, because the human has a size. Self height equals height. And self point name equals name. So classes can have its very own functions. Make a pretty simple one like print attributes. And it has name, weights, it has self point name, wait. So our very own function we have, which prints out our attributes. And now we can create our very own instance. Yeah, this is my bad language, of course. It has weight, not weight. So now we can create our very own instance. John is a human with the name John. He weighs 99 kilogram. And yeah, this is stupid because first we have the size, which is 199 centimeters, and the weight, which is 99 kilograms, and the name, which is John. So John point print attributes. Now if you click 1, John weighs 99 kilogram and has a size of 199 centimeters. Now we are finally heading to the inheritance. So we can create our very own subclass which has the same attributes as the human class, but we can add individual attributes which only bound to the subclass, and definitions which are also only be available at the subclass. So how does it work? So the next class we wanna create is class fatman, which inherited from human. So next thing we gonna write is a constructor function. In the constructor function we have another keyword, which is called super. So we are doing it like this, super, then we type in the brackets, then we type in init. Of course there has to be a point. And now this is we are writing this for creating our instance of the object human inside the fatman function. So while writing this, we can write in the brackets, for example, the name, which is the name, the size, which is the size, and just for the sake of showing you how it works, we won't use an attribute named weight, but weight will be automatically set to 150. Like this one. So now in the constructor function we first created an instance of a human, and now we are adding our very own attributes like number of scooters. This has to be written in lowercase. And now we can also add functions which are only available if we create a subclass, if we create the fatman class, like definition drive, and now we can write like no, not this one. Self point name is driving with one of his self point scooters. And we can also override functions which are already defined, like the print attributes function. We can write our very own attribute function, which is nearly the same than the old function, but with one really important difference, and has self point scooters at home. Now we can create our very own fatman, like are we gonna call him? We call him Michael. Michael is a fatman, has the name Michael, and has a size of 178 centimeters and has 3 scooters at home. Now if we type in Michael.print attributes, we will gonna get Michael weighs 150 kilograms, has a size of 178 centimeter and has 3 scooters at home. Now it's correct. So that's probably it. There's nothing more I got in my mind referring to inheritance. It's not my favorite topic, to be honest, because yeah, stuff like this, I'm more into inheritance in Java, but yeah, I wanted to show it because it's also a part of Python. And yeah, in some cases when we are going to the topic of multi-threading, I can show you that you also need some basic knowledge of inheritance, really some very basic knowledge of inheritance. But yeah, it's nice to know. Also, I don't use it that often when I'm writing something for myself. Have a nice evening, day, night, whatever time it is. See you in the next video. Bye bye. Hello, and welcome to the 13th part of our tutorial series about the Python basics. Now hitting our lucky number, and yeah, with our lucky number we have a data type which I really love to work with, and that are the dictionaries. So last two videos we had classes, and in Python classes are not my favorite topic, to be honest. I have to admit that, but now we are handling a data type I personally love. Yeah, what are dictionaries? Dictionaries do also store data values, but instead of a list, for example, a list uses, for example, indexes, and with the index you can get access to a certain element of the list. Now you don't have the index, but you have a key to get access to an element. So a dictionary stores not only an element, but a pair of a key and a value. And how that is looking, I will show you now. So by showing you will probably understand what I'm trying to explain. We have a dictionary we call Dicky, which begins with, and now that's important, brackets and curly brackets, to be more specific, because like lists have those square brackets, the dictionaries use curly brackets. So now we have our first entry, the key of our first pair, which is, I call it John, and now the value of John is pillow. Don't try to find out any higher meaning behind John and pillow. It's just born out of pure randomness. So next we add our next pair, which begins as a 3 as an integer and returns true. Then we add true as a key and the value is false. Our next key is false and our value is ASFD. Switched to German accidentally. And yes, then we have 88, and yeah, 88 is the key, but the value is another dictionary which has a key, and another dictionary which has a key, and another dictionary. So I guess this is a good example. And like most data types, we can simply print our dictionary. And now we get John, pillow, 3, true, true, false. I don't have to read anything, I guess. But to get access of a certain value, we have to type in Dicky, and then in square brackets we type in the key. Like we type the index if we want access to a certain element of a list. Now we type in, for example, John. Or we type in, for example, Dicky true. Now we are printing it. And yes, as you see, John returns, or with John we get access to the value pillow, and with true we get access to the value false. And we can combine, right, now I have a itch in my tongue, we can combine every kind of data type with any other kind of data type, except, for example, some data types are not to be used as keys, like a list. You shouldn't use a list as a key, but as a value you can use a list. You can write for colon. The colon is important too, but you already seen that I'm using colons. And yeah, then, for example, 3, 2, 4. This is possible, and now when we want Dicky 88 and then 4, we gain access to our list. So if we want to add another entry in our dictionary, we can just type dicky equals and then dicky, and then we type in our square bracket the key we wanna use, which can be oi equals tback. And now if we print our dictionary again, there should be a new entry at the end, and there is oi equals tback. And what we can't do is we can use the same key for two different entries or two different values. If we type again oi, but this time we type in, for example, 900 and print our dictionary again, we get oi and 900, because now you can call it overwritten, because it seems like oi is now overwritten and you get the value 900. So what else can I say about, or should I say about dictionaries? Dictionaries are still ordered. You can get the length of a dictionary if you just type in length of dictionary, like here, and it works like the length function of a list, and it gives back the number of pairs as an integer. What you can also get are the keys. Then you type in the name of your dictionaries and type in keys. And this prints the dictionary keys, but this is not a list. If you type now type of dictionary keys, you will get class dictionary keys. So the dictionary keys are an object, and we can, or a class, but we can type in a list of dictionary keys, and now you get a list of every key. And the same goes for the values. So we can also gain access to the values by typing print a list of dicky point values. And now you get everything which is marked as a value. And that's probably it. So I hope you liked the video. I guess this video was a little bit shorter, but yeah. Anyway, I love dictionaries. Hope you will get to like them too. Hope you have a wonderful evening, night, day, dinner time, whatever time it is. Have a good night. Bye bye.